Hello friends, we are seeing investment decision, project planning and control from SFM paper number 14. So far we have seen 5 methods under discounted cash flow method. Now we are going to see 6th method, that is modified internal rate of return. Before seeing the modified internal rate of return, let's see what are the difficulties in IRR method. The limitations or difficulties faced in IRR is explained in the illustration number 14. Here they are given calculate the IRR of a project having a following cash flow structure over its 4-year lifespan. Cash flow for year 0 is minus 2000, first year 1600, second year 2000, third year 2600 and fourth year minus 4400. Here they have given negative cash flows of minus 2000 in the current year and minus 4400 in the fourth year. If they have given in the negative, then it means outflow. So here cash outflow occur in the initial period and also in the subsequent period, that is fourth year. Usually outflow occur in the initial period alone. In that case we will not face any difficulties. Here the outflow occur in the initial period and also in the fourth year. If this is the case, it is known as non-conventional cash flow. Using these cash flows we have to find the IRR. So in the illustration they have solved the equation and found the IRR as 6.6% and 36.55%. Here two different IRR found. So selecting the project with the multiple IRR may be quite difficult. To avoid the limitation of multiple IRR, 6th method, modified IRR, is used. So what is the formula for modified IRR? Aggregate future value of cash inflow divided by aggregate present value of cash outflow, nth root of. So what is the formula for MIRR, modified internal rate of return? Nth root of aggregate future value of cash inflow divided by aggregate present value of cash outflow minus 1. This is for non-conventional cash flows, and for conventional cash flow MIRR is equal to nth root of aggregate future value of cash inflow divided by initial investment. So in the conventional cash flow we no need to find the present value of initial investment. So actual investment is considered. Whereas in the non-conventional cash flow, cash outflow occur in the subsequent period also. In that case we need to find the present value of cash outflows. How these formula arrives? We have already seen in the IRR, that is at IRR present value of cash inflow is equal to present value of cash outflows. Same procedure they have given, whereas one difference is here in the left hand side present value of cash outflow or initial investment, whereas in the right hand side they have considered aggregate future value of cash inflows. Divided by 1 plus MIRR power of n. So for bringing the future value to present value, we will divide the future value by 1 plus the rate power of nth period. So left hand side present value of outflow, right hand side present value of cash inflow. But before finding the present value of inflow, they have calculated the aggregate future value of cash inflow. Then they have divided it by 1 plus MIRR power of n. Okay, let's see illustration number 15. From the following information, calculate the MIRR of the project. Initial outlay 1 lakh, cost of capital 12% per annum, life of the project 5 year. Cash inflow from the project are 20,000, 30,000, 40,000, 50,000 and 30,000. In the formula what they have given, we have to find the aggregate future value of cash inflow. For finding the future value, we have to find the year for investment, then the future value is the cost of capital. So here we will find the future value at 12% for first year. So remaining year, we have remaining 4 years for investment. So 1 plus 12% is 1.12 1.12. We have to multiply the 1.12 into 4 times, that is 1.12 into 1.12 into 1.12 into 1.12. We will get 1.5735. Then we will multiply the future value factor with the cash inflow 20,000. We will arrive 31,470 as future value. Similarly, for second year, cash inflow is 30,000 in the second year. So remaining year out of the life of 5 years is 3 year remaining. 2 years are over. So for 3 year we are going to reinvest. So 1 plus 12% into 3 times we have to multiply. We will get 1.4049. Then after finding the future value factor, multiply it with the cash inflow, we will get 42,147. Similarly for third year, fourth year, fifth year. So in the fifth year we are in the end of the life of the project. So we are not going to reinvest any amount. So year for investment is 0. So 1 plus 12% power of 0 is 1. So 1 into 30,000 is 30,000. Then adding these found values for 5 year, we will get 2,09,793. And then MIRR is equal to nth root of aggregate future value of cash inflow, that is 2,09,793, and initial investment is 1 lakh minus 1. So 2,09,793 divided by 1 lakh, we will get 2.09793, power of 1 by 5 minus 1. Nth root means number of years. So for 5 years, so 1 by 5. Nth root will be written as power of 1 by 5. So power of 1 by 5, 1.15973 minus 1 is 0.15973. On this in percentage, multiply by 100, we will get 15.97%. Similar to the traditional IRR method, only difference is we have to find the future value for the reinvestment years. That is the remaining life of the project. The next method is modified NPV method. Okay, before seeing modified NPV method, let's see what are the limitations faced in the other method. In the NPV and IRR method, there is an assumption of constant reinvestment rate, whereas there is a possibility of a different reinvestment rate in the future period. In order to overcome these facilities, modified NPV methods are used. In this, we can use different reinvestment rate. Let's see an illustration. Number 16, a company is contemplating an investment project of 4 years with an initial outlay of 1,20,000. Cash inflows estimated from the project are 30,000, 40,000, 30,000 and 36,000. Estimated rate at which the above cash flows will be reinvested are. So they have given different reinvestment rate as 8 for first year, 9% for second year and 10% for third year and 9% for fourth year. Cost of capital is 10% per annum. Analyze the viability of the project under terminal value method. So in the previous method they only give the cost of capital, whereas here they have given different reinvestment rate for the life of the project. In the modified IRR method, reinvestment rate remain the same cost of capital. Okay, so year of reinvestment only the difference we are seeing. But here we see two changes, that is reinvestment rate and year of reinvestment. In the IRR, cost of capital remains the same for all the year. In the modified IRR method, the cost of capital given is 12% for all the year. Okay. Whereas in the modified NPV method, reinvestment rate is different for 4 years. And they have used the cost of capital for finding the present value alone, not for finding the future value. So for finding the future value, they are considering the reinvestment rate. For finding the present value, they are using the cost of capital 10% for 4 years. So modified NPV method is also known as terminal value method. So first step is we are finding the terminal value, that is future value, using the reinvestment rate and reinvestment year. And then we have to bring down the future value for the present value of 4th year. That is 1 divided by 1 plus 10% power of 4, which is 0.683. Multiplying with this, we will get 1,05,403. So we have calculated the present value of cash inflow. Then modified NPV is equal to the calculated cash inflow minus the outflow, that is 1,20,000, which is equal to minus 14,597. Here modified NPV is negative, so project is rejected. We are not accepting the project. We have completed the first concept, that is estimation of project cash flows using non-discounted and discounted cash flow methods. Let's see the other concept in the next videos. Thank you.